Okay, so we're going to look at the 5 and 1 from Friday. I'm looking at the afternoons. The multiple choice was the same. The free response was different, so I'm going to do the multiple choice in this video for both morning and afternoon. Okay, this first question, we kind of did one of these in the practice 5 and 1, which surprised me that so many of you missed it because we had done it the day before. But nonetheless, it's okay. We'll do it again because you probably will see it again on your test, so you need to make sure you know how to do it. Oh, wrong button. Okay, so if we do a direct substitution, we get the integral from 1 to 1, because if we put in 0 for x, we get 1 to 1. And anytime we have the integral from 1 to 1, that's 0. And then if we put in 0 for x, we get 0. So we get 0 over 0, and I got the wrong thing. We got 0 over 0, which means L'Hopital applies. Now you don't have to do this on a multiple choice. You have to do it, however, on a free response. So we say L'Hopital applies. So then we take the derivative of the top with respect to x, and now we are going, when we take that derivative, we have to use the fundamental theorem of calculus, which means since this is x and this is x, every place we see t, we replace it with x over 1 plus x. And we have to take the derivative of this. However, the derivative of 1 plus x is still just 1. And then taking the derivative of the denominator, we get 1. So now we're looking at the limit as x approaches 0. And if we do a direct substitution, we get cosine of 1 over 1 over 1. And cosine of 1 is simply cosine of 1. So the answer was E. I'm pretty sure. Yep, that is the correct answer. All right, so let's do the next one. This one, again, we have done many like this. It wasn't difficult. It was a little tedious because of the numbers. So what we want to see here is that if we do a direct substitution, we get 1. As this goes towards infinity, this goes towards 0. So we get 1 plus 0 raised to the infinity. And 1 to the infinity is indeterminate. And so we need to make it into either 0 over 0 or infinity over infinity so that we can use L'Hopital. So what we want to do is we want to say y is equal to the limit as x approaches infinity of 1 plus 2 over x raised to the 3x. Then if we take the natural log of y, when we take the natural log of both sides, the 3x drops, and we get the natural log of 1 plus 2 over x. And here's where we had to just be a little creative in our solving skills. So now we have the natural log of y is equal to the limit as x approaches infinity of the natural log of 1 plus 2 over x over 1 over 3x. Because remember, I said earlier that if we 1 over x times the natural log of x is the same as 1 over the natural log of x divided by 1 over x. Because if we multiply by the reciprocal, we go back to this. But if I do it this way and I take the limit as it approaches infinity, I get the natural log of 1, which is 0, and 1 over infinity gives me 0. So now I have infinity over infinity, so L'Hopital applies. So taking the derivative of the inner function, natural log of y, and I'm using L'Hopital, so I'm going to take the derivative of the numerator. So I start by taking the derivative of that inner function, which is going to give me negative 2 over x squared, divided by taking the derivative of natural log is 1 over 1 plus 2 over x. And the derivative of this will be negative 1 over 3 x squared. Okay? Now, I can use some algebra here. If I multiply by the reciprocal, I get the limit as x approaches infinity of negative 2x squared over 1 plus 2 over x times 3x squared over 1, and it's negative. So this cancels with this, and I am left with, let's see if I have enough room to write all of this. This up a little bit. I'm left with the natural log of y is equal to the limit as x approaches infinity. Those x squares cancel. Negative 2 times negative 3 gives me 6 over 1 plus 2 over x. And as I go towards infinity, that is simply 6, because this becomes 0, and so this is 6. So, but remember, this is the natural log of y equals 6, so y is equal to e to the 6th. And I think that was the answer. Yay. Okie dokie. Again, this one is just using the formula to find the derivative. What is the slope of the line tangent? So we're just trying to find the derivative. So the derivative would be y prime is equal to the derivative of the inner function is 4 times arctan of 4x is 1 over 4 quantity x squared, which is, if I'm evaluating this as x fourth, but we can write it as y prime is 1 plus 16x squared, and y prime of 1/4 is equal to 4 plus 1 plus 16 times 1 over 4 quantity squared, which this becomes 1 because that's 16 over 16. So that's 1. So 1 plus 1 is 2. So I get 4 over 2. So my answer is 2. Okie dokie. This one. Yeah, Mrs. Zamora was really proud of this one. And it really wasn't a bad problem. It just required a lot of trig and a lot of remembering the unit circle. But you need to know the unit circle. So remember, in these situations, this is y. So I'm going to set 2, the square root of radical 3, equal to cosecant of 5x. So this becomes cosecant inverse of 2 over radical 3 is equal to 5x. So the answer to that, using my unit circle, is pi over 3. So I get pi over 3 is equal to 5x. So x is equal to pi over 15. Alrighty? So this is my new y. This is the x for the inverse. So now I'm going to use the formula 1 over f prime of pi over 15. Okay? So now I need to find the derivative of this. So f prime of x is equal to 5. The derivative of cosecant 5x is cosecant x, cotangent x. And evaluating that at pi over 3, I'm sorry, it's, I wrote that wrong. Chain rule. That is 5x times cotangent of 5x, and it's also negative. All the derivative of the codes are negative. So f prime of pi over 15 is negative 5 cosecant, or when I put pi over 15 in there, I get pi over 3. Cotangent, pi over 3. And using my unit circle, I find this to be, negative 10 over 3. But because I am doing 1 over that, so 1 over negative 10 over 3 is negative 3 over 10. And so B is the correct answer. Yeah, I know. Okay. And the average value on this one, when I did this, honestly, where I made my mistake was, even though I began by writing it as 1 over pi over 2 times the integral, because we're looking for average value from 0 to pi over 2 of sine x for cosine x. By the time I had finished, I forgot to multiply by pi over 2. It should be 1 over pi over 2. And the reason we get this is because it's pi over 2 minus 0, and we have to do 1 over that to find the average value. Alrighty, so let's do a u sub. So u is equal to cosine x. So du is equal to negative sine x. I'm going to go ahead and change my variables. U of 0, so u of cosine is 1. U of pi over 2 is 0. So substituting everything in, I get, and taking the reciprocal of that, I get 2 over pi negative, because that negative has to come on the outside. The integral, changing my limit, now goes from 1 to 0 of 4u du. Okay, now what I need to do is I want to get rid of this negative and put it so that I have a smaller one on the bottom, so I can say this is 2 over pi, integral from 0 to 1 of 4u du, and taking the integral of that, 2 over pi, is 1 over the natural log of 4 times 4 to the u, evaluated from 0 to 1, which gives us 2 over pi times 4 minus 4 to the 0 over the natural log of 4, which gives us 2 over pi times 3 over the natural log of 4. And a lot of you probably chose 3 over the natural log of 4. That's what I chose the first time. But then we have to remember to multiply by 2 over pi. So the correct answer is actually A. Okay, I think that's it. So that's it for the multiple choice. Depending on if you're afternoon or morning, you probably want to watch the free response question. All right, guys, do well on your test tomorrow. Miss you.